Now fifth problem on pyramid. A pentagonal pyramid side of base 30 mm and axis 60 mm long stands on an edge of base on the HP. So again, if it is lying on one of the base edge on the HP, so my assumption for the first edge will be the entire base is lying on the HP. So again, we need to start with the top view, that is below XY line, with one of the edge of the pentagon perpendicular to XY and on the right hand side. The edge makes an angle 45 degree to the with the VP. Now, as I told before, that condition with the VP will be always used for redrawing the top view. So in that case, we are in this first stage we are starting with the top view, then front view. Then in second stage we will be redrawing the front view. So this condition will not be used for second stage since it is given with the VP. So after completing the top view in second stage, we will use this for redrawing in third stage. Draw its projection if the apex is 40 mm above the HP. Now here, no inclination is directly given, but indirectly apex position is given with respect to HP. So this condition we have to use for redrawing the front view in second stage because it is with respect to HP and nearer to the observer. Now the apex is nearer to the observer, and this condition nearer to the observer will be used in again third stage. So we will start with the solution. First stage is same as done in previous 4 problems. Drawing the pentagonal base in the top view with one of the base edge perpendicular to XY line and on the right hand side. And here the dimensions given for base edge and axis length. Base edge is 30, so I will draw the pentagon of 30 mm side. Then marking the angles. You can just rush through these stages as we have already done in previous problems. Not it again. Okay. Then we will draw the angles. Sorry, edges. It was not it. To verify this angle again. Yeah, it's right, one not it. So on that we are going to mark that 30 mm length again. Then completing the remaining 2 edges. So now we'll make the pentagon dark and then we'll mark the center of the base to draw the slant edges. So 30, so we'll mark the midpoint as 15 from any two sides to mark the center of the base. Okay, now this will give me the apex. So we need to make the slant edges dark, which are apparent in top view. So after drawing the base, we'll show the notations 1, 2, 3, 4, 5 and then O. Now we'll complete the corresponding front view. Just need to project the apex up to the axis length of 60 mm. So on this line, we need to mark 60 mm long dash short dash. Okay. Now we need to project the other points up to XY line and not up to the axis length. So 2 and 5 get the same projector, and then for 1. Now making the boundary dark, then drawing the base dark, then this slant edge again dark, then we will transfer the notation 1 dash, then 2 dash comma 5 dash, 2 dash and 4 dash, 3 dash comma 4 dash. Now in second stage, we need to use this condition which is with the HP. Now here direct inclination is not given for any axis or triangular surface. So for that, what is given is apex is 40 mm above the HP, means this point O dash, which is now at a distance 60 mm from the XY line. So we need to tilt this front view such that this apex will come at 40 mm, keeping this edge 3 dash 4 dash till on XY line. So first I'll mark 3 dash 4 dash because anyhow we have to keep that edge, base edge on the XY. Now I'll mark a parallel line to XY at a distance 40 mm. Sorry. So total length is axis up to axis is 60. So this 2 will give me total length of 40. So we will draw a parallel line at 40 mm from XY line because the apex is in second stage, apex is 40 mm above the HP. Okay. Now we have the length 3 dash 4 dash up to apex, and we are sure that apex is going to lie on this line which is 40 mm above the XY. So with 3 dash 4 dash, I'll cut the arc on this line. So this will give me the position of apex. Now this is satisfying the condition apex is 40 mm above the HP for second stage. Now I will complete the remaining rectangle with 3 dash 4 dash. I'll mark an arc for 1 dash. Okay, and with O dash, I'll again cut the arc for 1 dash. They are intersecting here. So this point will give me 1 dash. So I'll join 3 dash 4 dash to O dash, and then making the boundary of the rectangle dark. Now I'll mark other 2 points 3 dash 4 dash to O dash, and then 3 dash 4 dash to 2 dash 5 dash. Axis will be long dash short dash. And the slant edge will be a dark line. So O dash, then 2 dash and 5 dash. Now we'll complete the top view in second stage by just projecting all the corners, all the points from front view. And finally from top view. and locate the points 1 dash, so 1, 2 and 5 on this line, so 5 will be here, 2 will be here, then 4 will be here and 3 will be here, then center of the base O and apex here. Now again making the boundary dark, so I think visibility will be same as the previous problems where we made that triangular face inclined at 45 degree. So again O25 is lying on the boundary, then O22 again lying on the boundary, 3 and 4 are the farthest points from the observer, so all the edges from those points will be hidden, dotted, if they are not lying on the boundary. So 4 to 5, 4 to O and 4 to 3 all will be dotted because 4 is the farthest point. Similarly 3 is farthest point, so 3 to 4 already made dotted, then 3 to 2 and then remaining is 3 to O again dotted. Okay. Now remaining slant edges are O to 1, only O to 1, so it is nearer to the observer, so it should be dark. Okay. Check whether all the edges are drawn. Yes. Now no need to show the axis because it is coinciding with O1. Now we'll move to the next stage. So we need to redraw this top view such that the edge makes an angle 45 degree with the BP. Because while redrawing the top view, we need condition with the BP. Now the edge is the same edge which is kept in the HP initially, that is 3 4 dash 4 dash, which I am getting again here. So which is giving me again the true length. So I can directly mark 45 degree, which is the true inclination. So first, and again as did in previous problem, if I want to make this edge inclined at 45 degree, so obviously if I am first redrawing this rectangle in which the entire top view is included, so I can make this edge of the rectangle inclined at 45 degrees. So obviously after drawing parallel line for 3 and 4, I can get that line also inclined at 45 degrees. So first I'll randomly mark a point, and first we need to check how to tilt. For that we need to read the last part nearer to the observer. That means the apex should be nearer to the observer. Means observer is going to look from this direction. So this I need to tilt like this so that apex will come down nearer to the observer. So first I'll mark the 45 degree angle to redraw that rectangle such that the one of the boundary lies on that 45 degree inclination. This is almost similar to the previous problem, but only conditions given are different. But I think the positions are same. So I'll mark this length of the rectangle first, this boundary, starting with any random point. Now because this is the extreme point, so nothing will come above this. So after marking one side of the rectangle, we'll draw two perpendiculars from each end of the rectangle to get the other two sides of the rectangle. So here it is 90, again here it is 90. So we'll complete that rectangular box in which the entire top view is included. So after marking those lines, I'll mark the length of the rectangle, which will be same. So after marking these two arcs, I'll join to get the rectangle in which the entire top view is included. So this should be light. By mistake, I drawn it in dark. Okay. Now After making this boundary, I'll mark those points. For first, starting with this corner, I can mark 5 and same distance will be taken for 2 also. So this arc will give me 5 and this arc will give me 2. Okay. Then I need to mark the midpoint of this side of the rectangle to get 1. Okay. So here I'll mark the arc to get 1, and if I draw parallel line to the boundary of the rectangle through 1 on the same point or on the same line, I'll get the apex here O, and one more O which is the center of the base on that line. So these points already marked are 5 and 2. Again, for drawing this 3, 4 parallel to this edge of the rectangle, I need the parallel distance which can be marked on this line from 1. So I'll mark that distance. Now I'll draw a parallel line to this edge of the rectangle to get the edge 3, 4. Now again, to mark 3 and 4, I take the distance from the center, which will be same on both the sides for 3 as well as 4. Okay. Now from this center, I'll mark those 2 points. So point nearer to 5 will be 4 and point nearer to 2 will be 3. So again, after marking all the points, we will join with the same visibility. Then go to 2 on the boundary, go to 5 again on the boundary, and then remaining are dotted. Same visibility. Then 3 to 4 dotted again. Then 5 to 4. Because 3 and 4 are the farthest point, and then 2 to 3. And then O to 1 is again dark line. So check again. Okay, all the notations are shown with the same visibility. Now we'll complete the final view. Here see 4 and 5, projectors from 4 and 5 are coinciding. And then, sorry, I forgot to draw from O, which is the center of the base. Okay. Now we'll transfer from front view. First is center of the base O dash, then 2 dash 5 dash, then apex, and then 1 dash. Okay. Now we'll locate the points, starting with 2 dash here, then 3 on the XY line, 3 dash, then 1 at the top, 1 dash, then 5 and 4 will be same on the same projectors. So 4 dash will be here and 5 dash above on the same line from 2 dash. Then apex is here, 2 dash. Then center of the base here, 2 dash. Now we'll join. O1 is on the boundary, one of the slant edge, one of the base edge, 1 dash 2 dash on the boundary, again 2 dash 3 dash on the boundary, and 3 dash 4 dash also on the boundary, and 4 dash O dash on the boundary. Okay. Now again, observer position is this. Phi is the farthest point for the observer. So all the three lines starting from phi dash will be hidden, that is dotted, because it is the farthest corner for the observer. So first 4 dash phi dash hidden, phi dash O dash, which is the slant edge, again hidden, in phi dash 1 dash, again a hidden line, dotted line. Now we have completed all the 5 edges of the base, and from the slant edges we have covered 3 edges, O dash 1 dash, O dash phi dash, and O dash 4 dash. Now 2 dash O dash and 3 dash O dash. For that, 2 dash O dash is nearer to the observer, also 3 to O is also nearer to the observer. I think we have forgot to mark these two sides in the previous problem, these two slant edges. So here the visibility will be same. That means both slant edges are visible. So make the correction in the previous problem, that is the fourth problem. I think by mistake we forgot to draw these two lines, slant edges. So those lines should be dotted. Visibility is similar to this problem. Now marking the axis, O dash by long dash short dash. So this completes the solution. Again, we need to show dimensions, base edges, which is 30 mm, and axis height is 60 mm. Then for second stage, the condition given was apex is at 40 mm, so I'll show that distance also. And for the last, this 3-4 is inclined at 45 degrees, so I'll show phi is equal to 45 degrees. We are not directly making 3-4 inclined at 45, we are making one of the boundary of the rectangle and then 3-4, because if you directly start with 3-4 at this point, but above this 3-4 some part is also lying there, so it may, after drawing it may cut xy, so we'll start with the extreme boundary of the rectangle, then we'll redraw the 3-4. Okay, so this completes the solution for this particular problem.